Hey everybody, this is Larry. We'll move the heads. Hit the like button, hit the subscribe button. It's the 6th day of the Leetcode Daily Challenge in August. Join me on Discord. Come ask questions and be friends and all that stuff. Cool. Find all duplicates in an array. Given an array of integers from 1 to n, some elements appear twice and others appear once. Find all elements that appear twice in this array. Could you do it without extra space and over n times? In place is always kind of a little bit weird, but we could definitely do that. I think also the phrasing is a little bit weird. I think because you need the extra space to return the duplicates probably, but I'm gonna use that extra space because I don't know. I mean, the alternative is just remove elements from the input list, which is kind of silly, right? So, and that's just like a silly exercise. But I think the key thing to know here is that each number is between 1 to n. So that means that if you put things in there where they should be, in theory, yeah, each number should already be. Yeah, if you put things where they should be, then if multiple places map to the same bucket, then there'll be duplicates. I think that's right, from 0 to 1 to n inclusive. And then, for example, we would try to put 1 in the first cell and 2 in the second cell, and then there's two 2s, so then now we know the two 2s. And if we do it that way, that'll be n squared. But if we just do it in a permutational cycle kind of way, then we can do it in linear time. And what do I mean by permutation cycle? What I mean is just we go from left to right, and we just move them from 4. Okay, let's go to 4, and then 7, move to 7, so forth, and then we should be okay. Yeah, let's do that. So let's keep track of the index that we're processing, and then also like a current index. Also, the extra space is kind of weird because now we're using extra space already, right? So it really depends on what they mean. But yeah, current is equal to none, say. So now we do while index is less than n, and is equal to nums. Okay. Right, so let's just say current is equal to num sub index. And then we want to put this in num sub current. Yeah. Num sub current minus 1, right? Because this goes from 1 to n, which is 0 to n minus 1. So once set this is equal to current. So, okay. So if num sub current 1 is equal to current, then that means that we already did this, and that means that this is a duplicate maybe. But also we want to set current is not equal to index. If yeah, if current is not equal to index and this, because otherwise then it just started already in place, right? So then you don't have to do it. Is it current minus 1 though? It's not equal to index minus 1. Then we set this is true, and then yeah, then that should be okay. And then we want to do previous is equal to num sub, because now we have to move this one, right? And if previous that means that the number that's current there is already equal to current, then that means that we have a dupe. And then now we set it, and then we do previous is equal to current. Oh, sorry, current is equal to previous, and then we swap this number, right? So then now we just do maybe this is a while loop, and that should be okay. Maybe I think I'm possibly missing something, to be honest, but I think that should be a good start for me to kind of play around with it. Yeah. Okay. And it's usually these in-place algorithms are a little bit weird because, oops, because you're literally changing the input, right? But we can play around for now. So okay, so we actually did no swaps. Is that right? Oh, is this true? I think this is when this is not true. Oops. Okay, so it does get sorted, but we don't put the answer, so that's a little bit awkward. But that's okay. We could probably figure out. Oh, because this is now no longer true, so this never does all this stuff. Okay. Yeah, I mean, I think for problems like this, we have to think about the invariant, and that will determine your loops. I am a little bit bad at this one, I suppose. Does this needs to be true? I guess not. I guess it's just that current is now you go to index 1. Should be okay. Oh, wait, I think we do have to... We need that check, just not initially. So I think maybe here. Oops. So, is that right? No. Just let me think about this for a second. So while this is not true, then previous. Oh, if this is true, then we break because then we found our duplicate. Okay, this is a little bit awkward. Oh wait, I have to figure out one more invariant. I think if this is true, then we just continue because that means that the thing is already in place, but that doesn't fix this. So that, but let's wanted to see what it gets us. This should not tell you though, because without this didn't tell you. Oh, well, yeah, because I don't index +1. Okay, that was just silly on my part. Because I'm used to having it as for loop. Okay. That's certainly unexpected. And now I guess I'm just thinking whether I have an off, because this is really awkwardly off by 1, so oops. Just want to check another example. Okay, that's still wrong, huh? So this 3 tries to go to 3 and it's successful. Oh, I see. Because I don't get rid of the... I thought that I didn't need to, but I was wrong on this one. Which is that once we set this, we actually want the numbers of indexes equal to say none, so that we mark it as being done. Though this may break other stuff, but I want to see what happens here. Yeah, okay. Okay. I guess this is slightly better, but not really. This is a little bit awkward because I think this is not right. There's a lot of off by ones in this case, even though in the algorithm in my head it was right, but I think I'm just a little bit off by one. If this index is already good, then we don't have to take care of it. This is wait. So when do we skip this index? This index is good when. Okay. Start with that because I think whatever I had before was a little bit weird. Okay, so this looks a little bit better, though in this case it's still not great. 1 and then 1 goes 2, but 2, like these should be nuns, I think, now that we changed our code in a good way, so that we don't process it in the future. So okay, another way that we can also debug, and maybe this is a good lesson debugging, just to looking at the progress step by step. So okay, so after one iteration, we move 1 here. Okay, that's good. Sorry, move to 4 here, that is, and then move the 7 goes to the 7, and then the 3 goes to the 3. So it's like a little bit of a sort. Okay, and then 2 is good. So we don't care for it, I think. Why is this none? Well, how did this get to 8? 1, 2. I think that is a good question. Oh, I guess because it skipped a few, so it didn't get printed. Okay. So it skipped 2, 3, 4, and then on 8, it moves the 8 to the back, it moves the 1 to the front, and that's good. And then, but here it does not. No, it does the 2. Also, yeah, okay. This is the same as this. I noticed, but why is this 2 not none? Oh, I guess because we have this, we just loop and then break. But let's actually make sure that we. I think that's why. Okay. Oh, and also this is not in. Okay, this should not be indexed because this should be updated, which is current -1. Okay. So just a couple of silly typos. Now it looks different. I don't know if it's better. Oh, this is a little bit weird the way that I did it. Okay, so this is the old ones. Oh, we want to mark removing the current, right? So I think this is just current is equal to done, none. Is that right? I don't think so, actually. Let me think about this. Okay, because I'm mixing this. The 0 index and the 1 index is a little bit messy. I should have just kept it consistent, and all these things would be a little bit better. But so okay, so the previous number that was here is in the current price. Okay, and then now we move it from the previous number. So it should be index. I mean, I think that part is actually technically right, but after one iteration, what is it, right? I think this loop is all weird because I'm mixing current and index and stuff in a weird usage in a weird way. This should not be that much of a struggle, but I am struggling a little bit today, which is good practice, I suppose. But okay, so in the beginning, current and index should not be. Okay, that makes sense. And then now we move that around. Okay. well, the current should be the current, because I use current to represent the value and the index, which is why it's a little bit weird. And then now the previous, so let's say we're moving 4 to 7. We take the 7, so this is 7. We want to set this is, so yeah, so we want to set this is equal to none, which is technically true, but then it's just that now I guess this works actually because we only need to set the initial one, because all the other ones of the cycle will get matched up. Now that I think about it. Okay, so this works for this case, and actually looks good step by step, but not so much for this case. Why is that? 1, so this moves, 2 goes here, that's good, and then goes to here, but then it removes it, but then not put it in the duplicate. So basically, this is all true, and it does remove it. It's just that, okay, the current would be 3, and 3 is definitely not in the, or the 2 is not in the right place. So this becomes, okay, fine, let's just print it out instead of guessing the states. Okay, so we start here, none, okay. So it doesn't even go into this loop, it just takes this, it changes it to none, and then that's why. Huh. So the index is 3. Oh, I guess this condition is just wrong. I think, okay, that's just a silly typo then. A lot of issues today. Thanks for bearing with me. Looks okay. Yeah, I think this shows you that, no, let me submit it. I think I'm okay. But yeah, this, hopefully. Oh no, wrong answer. Okay, so maybe not. But it shows you that even when you know the algorithm right off the bat, sometimes you're going to run into implementation issues. And I think that's also, to be honest, this is not something I practice because I don't really do in-place stuff. But that said, you know, that's why you do this, is so that you get this practice. But okay, so 1, so 10 goes to 10, which moves to 7, and okay. And we go to this 1. Oh, that's a little bit odd. Because I guess this 1 did not get back to here. And which is, I guess this is the problem with this, is that it loops back. What we want is actually the current is not equal to, that's what this condition was wrong. It's basically, if you have a complete cycle, it doesn't loop back to the first item, is what's happening. I think actually we do maybe that. Okay, maybe not. So what we're saying is, while the number that we have right now is not in the right place, should be right, because this current should be 1, and then I think so. Maybe put it here. Just a lot of silly cases on my end. Okay. Okay, I just print it out then. Now, because current is none, but so okay. So this moves to 7, and then it moves to 1, but it doesn't set the 1, right? So current is 1, right? And it's definitely like this. Oh, I guess no, that doesn't make sense. Maybe pre. Yeah, the previous is 1. Why are they the same? Did I mess it up? I mean, this just by definition. Okay, let's see. 710, 17, that's good. And then none 1, also kind of good. Because previous is none, so this is not true. Now this is right. I guess I fixed something that fixes it, but it just doesn't count the dupes. Because now the array looks right. It's just the dupe checking is wrong because previous is none, I suppose. Let's take a look. So after 1 cycle is this, and 2 is this, which still makes sense so far. 3 is good. 5 and then 4. But how come it doesn't do this one? This is very frustrating, but oh, because this is true to begin with. And because this is true to begin with, okay, I have to do something. I thought I had something like this, but I don't think this fixes it actually, but because I think it just moves that thing up, yeah, and then it doesn't check none. Okay, I want to do something like, I think if this is true, okay, now let's try again. Okay, cool. Yeah, I mean, this is only 20 lines, 25 lines of code or so. Definitely have a lot of issues with silly mistakes. This took way too long. This is a long video, but I hope that the algorithm is okay. It's linear time because we look at each item at most once. And we don't really use extra space except for to return values and and like these variables. Yeah, I mean, I think the algorithm is easy to explain, but I definitely struggled with the invariant and making sure that everything was true and right. Let me know what you think, and I will see you tomorrow. Bye bye.